Okay, so this problem is asking about work done, and obviously our normal formula is work done is equal to force times distance. We're given information about the distance, but not about the force directly, so we also need to remember that force is mass times acceleration. Now, the mass is constant at 40 kilograms, so we can just simply apply F equals ma directly. And actually, just to save time, I'm going to just apply it to this graph. I can make this now a graph of force by multiplying by 40. So this becomes 800 and this becomes 400. And now I've got a graph of force against distance. Now, there's a general thing in physics that if we've got a formula where we're multiplying, but both of the quantities are changing, and you can see from the graph that they're definitely changing. This force isn't constant. It's definitely something weird is happening at 2 meters, for example. So rather than multiplying, we have to look at the area under the graph. Okay, so if you're multiplying, then that's equivalent to the area under the graph if both quantities are changing. Okay, if you're wanting to think about calculus, then rather than saying that work done is force times distance, we're kind of saying it's the integral of force with respect to distance, okay, which is, as you know, integral is area under the graph. Okay, so this is obviously a bit of an odd looking graph, and so we'll just break it into two more common shapes. So I've got a rectangle here, and then I've got a little triangle up here. And so the height of the rectangle is 400 times 4. So this rectangle is 400 times 4, which is equal to 1,600. And this little triangle here is half base times height. So it's half times 2 is the base. It's going from 2 to 4. And then the height is 400 because it's going from 400 to 800. So that little bit here is 400. So half times 2 times 400 is just 400. Okay, so I'm going to add these two together and get the final answer of work done is 2,000 joules.